Hello and good day. We are from Group 4 are going to present to you about a case study regarding the geotextile tube for shoreline protection in the Incheon Beach of Korea. So the group members for this group are as shown as follows. For an introduction, the shoreline erosion has become one of the most alarming events in the past few decades. Traditionally, this coastal erosion protection has used natural rocks for its protection, but due to its scarcity of the natural resources, the switch from the traditional materials has evolved to some environmental friendly materials, and these environmental friendly materials are geosynthetics. So the usage of geosynthetic material has been widely adopted due to its cheaper price and their environmental properties. So the geotextiles that have been used in this case study are geotextile tubes. Generally, these geotextile tubes have been employed in many shoreline protection projects in the world. So for this case study, we are focusing on the shoreline protection along the Incheon Beach of South Korea. So the figure shown here is the start location for this case study.
Hi, I am Abdul Hamid Zibir Abdullah. Today I will present my part. My part is design of geotextile. So the geotextile tube is made out of permeable fabric, and the standard size of geotextile sheet is about 4 to 5 meter width, which is inlet and outlet is located at a regular intervals. So there are two main part of geotextile. The first one is inner tube. Inner tube act as a filter that retains the fine grained material, while the outer liner of high strength woven designed to high strength to remains the weight of the fill material and the pumping pressure to refills the tube. So the sand and water at a ratio 1 to 5 was pumped into the tube section. Excess water is escaped to the outlet. So what can I have conclude is geotextile with the high permeable fill material has better internal and external stability than non-permeable fabrics form. The the next one is design consideration, design of strength. The first one is strength of the tensile and steam strength. The second one resistant against long-term exposures to UV. The third one is resistant against abrasion, tearing strength, punching strength. And the last one is flattening behavior, which is the geotextile tube surface by the consolidation of the inside filling material. The, the last one is properties of polypropylenes of geotextile tube. So there are properties which is composition, weight, mechanical, tensile strength, tensile allocations, burst strength. So this table will express is more detail about the parameters of the properties. So that's all from me. Thank you.
Okay, so next for the geotextile design. So the figure shows the layout of the monitoring system, three-dimensional layout of geotextile, and also the cross-sectional of the geotextile tube. So for the value of the cross-section, with the height of 2.3 meter, and also have the 2.2 meter, with the width 6 meter. Moreover, for the length is it can reach about 610 meter. Okay, so for the design calculation, the main problem is in geotextile tube technology are the lack of the proper design criteria, which is for factors such as the hydraulic stability and also the structure functionality. So geotextile tube structure can fail for many reasons, like sliding, overturning, bearing capacity failure, and also the migration of the sand in the tube. In order to assess the stability of a filled geotextile tube structure, current wave force have to be estimated. So in this paper, the theoretical stability analysis employed is a two-dimensional hydraulic stability analysis based on linear wave theory and the geometrical stability analysis method. So a pull certain load to a geotextile tube is evaluated by Heroy's empirical equation. So this is the equation. PW equal to 1.5. Then the other equation that we use is safety factor against the sliding. The next is safety factor against the overturning, and also the bearing capacity. Okay, then stability analysis was carried out for the sliding, overturning, and also the bearing capacity failure, which is for the stack geotextile tube, and the result are tabulated in the table 2. So as you can see is the table for the stability analysis, which is for the overturning, sliding, and also the bearing capacity failure.
The installation of geotextile tube at the site. First is score aprons and base of polyester mats were placed on the site. Second is to fit the apron and mats from the water currents. Sandbags were placed on the mats. Third is 120 mm diameter post pipe were put on the seabed ground so that the geotextile tube could be strapped to them. Fourth is geotextile tube was securely fastened to the post pipe, ensuring precise alignment during the filling process. Fifth is after installing the geotextile tube, sand was pumped into the tube by the float tide underwater. Sixth is injection were carried out in partially submerged or underwater condition. Seven is under submerged condition, the geotextile was 50 meter long and the tube was 5 meter diameter at the first layer. And the lastly is the spacing between an inlet and outlet was 50 meter in the construction. The application of geotextile tube in advantage for the construction. First is geotextile tube solution can save money, construction time, and carbon footprint when compared with rock fill option. Second is same fillet geotextile tube structure have also been found to generate smaller carbon footprint when compared with equivalent structure. Third is rock fill placement can induce high impact stress and disturbance in soft ground condition. Fourth is this installation process can result in significant loss of material due to punching in of the rock fill into the soft clay seabed. And the lastly is less loss of construction material into the soft clay seabed. Thank you.
So for conclusion and recommendation, the design principles include methods for assessing cross-sectional forms, circumferential tension, and top and bottom pressures. Next, it is important to consider not only its structural stability but also its high reduction due to settlement caused by conditions such as low pressure filling. And then, in terms of application, geotextile tube is proven to be very successful in the construction of a sea dike and the protection of the beach line from sea wave erosion. The flexibility of the fabric structure of the geotextile tube provide ready adaptation to various landforms and field conditions. And then for recommendation, ensure right placement and design of the geotextile tube so that the application is more effective. Thank you.